everyone. I am Lena, your host for today. I am thrilled to introduce Shozab Raza, the first person to be contacted by time-traveling future beings. He offers valuable insights into humanity's future. Please welcome Shozab.
This was the intro that I wanted to make. Hello everyone, my name is Shozab Raza and I am a DMI graduate student and I'm set to graduate this month, hopefully, if I do this right. So, first of all, we will start with talking about the relationship between humans and machines. Secondly, we will talk about how humans make machines and how in return machines make humans. Lastly, we will try to speculate the future of machines.
It sounds like quite an adventure. I'm eager to learn more about it. Let's begin with your fascination with machines and humans. What drives your interest in this area?
Nice question. So, in order to see where my interest in humans and machines lie, we should probably go back to my childhood. I was born in Sialkot, which is an industrial town, and it's popular for exporting stainless steel equipment, sports equipment, and also leather garments. One fun fact about Sialkot is that the award for the best football ever made in 2022 was given to Sialkot. And by football, I'm talking about real football. My dad, fortunately for me, he owns a stainless steel factory. And in Sialkot, there's a huge economic disparity between different classes of people. You either own a factory or you work at one. This is Amjad, who works at my dad's factory. He is a blacksmith. And since I was a kid, I was always surrounded by machines, working with humans in order to make more machines. So I was surrounded by different kinds of machines, sandblasters, wire cutters, metal benders, CNC machines, etc. So I think that is where the fascination for machine comes from. On the other hand, my relationship with humans is a bit different. It's a bit complicated. I belong to a Shia minority sect in Islam, and some schools of thought in Shiaism involve the practice of self-flagellation every year in commemoration of Hussein, who was the grandson of Prophet Muhammad. So I used to go to these processions with my uncles, my dad, my cousins, and I used to watch these men swinging sharp blades attached to wooden handles and hitting their backs. Their wounds grew deeper and bigger, and there was blood everywhere. There was this one splash of blood that smacked my face when I was 10 years old, and that usurped my entire visual expression in my art. So this one illustration actually depicts these two different materialities interacting with each other in an abstract manner. You can see organic stuff, bones, flesh, guts, bones, which is the very visceral form of the human body. And on the other hand, you can see different kinds of mechanical components that are integrated with the organic forms.
Machines and guts are an intriguing combination. I sense a duality here, with two distinct material aspects. Could you elaborate on this for our audience?
Of course, Lena. So, let's talk about that. You guys are laughing. So, whenever we think about matter, we usually categorize it into two different distinct categories: organic or synthetic. Organic, which is nature-made, and synthetic, which is man-made. In these two images, you can see that these two different materialities can be very complicated. Humans design complicated things as well. But of course, nature does it the best. Um, the thing is that we as humans, we want to improve ourselves all the time, and we make machines in order to do that. So you see this weird tension between these two different materialities because organic and synthetic doesn't really go well together. And we as humans still love to be one with these machines. A great example for that could be Iron Man, because everyone loves superheroes like Iron Man because they are highly believable. Because if you think about Superman, it's hard to believe that you can get abilities like Superman. But when you look at Iron Man, Tony Stark, he's got all he's got all the abilities that you probably might be able to attain in the next few years. We can fly already. We have AI programs that we can talk to, and well, that actually is a very interesting idea because everyone thinks that a cyborg needs to have a mechanical body or it needs to look like Iron Man visually. But I think that that's not the case because my eyeglasses that I'm wearing right now, they make me a cyborg because I'm using a machine that enhances my ability to see things. So let's talk about the intimate relationship between humans and machines. Um, who do you think knows the most about you? Is it your family? Is it your spouse? Are those your siblings? I would say no. I think it's this little device that we hold in our hands all the time and in our pockets. It knows what you like, it knows what you dislike, it knows who you love, it knows who you hate. It also knows, I don't want to talk about that. So let's think about a bed. When I talk about machines, I talk about machines in a very broad manner. Anything that's a tool that helps humans in any way can be called a machine. I think it comes from a Latin word "macos," which means expedient, which helps which helps humans in totality. So with a bed, you sleep with a bed every night. Most of us do now, and you don't sleep with anyone else that much. So I think your bed is your lover. Let's think about a chair, which is an interesting one, because a chair remembers the contours of your buttocks. Imagine how intimate that is.
It's fascinating how closely humans and machines are intertwined. I empathize with the chair, though. Will machines become even more integrated with us in the future?
As famously Einstein said, in order to understand the future, we must look into the past. So let's go into the past. One of the earliest technologies that we discovered was fire. And fire protected us, but it also gave us the ability to cook food. And by eating cooked food, the human body did not need enough energy to digest the food. And due to that reason, the prefrontal cortex of our brains actually grew bigger because all the energy went up to our brains. So that is how a machine influenced the human form. We have newer machines now, complicated machines. We have computers and phones now, and they are mere extensions of the human brain. And they assist us. We can offload information onto our devices. So what makes you think that the technologies of the future would actually look like a smartphone or a screen? I think that's highly unlikely because the difference between fire and a cell phone is drastic. And I don't think that the material form of a machine in the future would actually look like a phone. So let's go back to Iron Man. He's got an AI assistant, Jarvis, and he talks to Jarvis, and Jarvis helps him beat bad guys. So people put faith in technology sometimes too much, but that's what it takes to be human. So this guy, Nolan Arnott, is the first person to be implanted with the brain-computer interface chip. So what this chip does is it allows you to control a computer without using your hands or your legs. This was a very successful experiment. It was surgically implanted into his brain. So they drilled his brain and they put a chip inside it, which is very scary. And he was able to play 3 different video games: digital chess, Mario Kart, and surprisingly, this game, Civilization 6. It's a very complicated game, and it's hard to imagine that you can play a video game just by using your brain, which is as complex as this little thing over here. But there are many other ways. I always, I don't like the idea of surgically implanting something in your body. And the reason for that is, again, the 2 different materialities, because it's chips, metal, wires, and we don't like the idea of putting that into ourselves. So maybe a way of designing machines in the future could be different. It could be probably more a claim to the type of body that we have. So this is an example. Neri Oxman, she was a professor at the MIT Media Lab, and now she runs her own company in New York. And she made this project. It's called Vespers 3. These are little masks. She calls it death masks. So they actually capture the last breath of a dying person, and they become biological urns for that person. And it is made entirely organically, and it does not involve any chips or wires or panels. So,
the future sounds both thrilling and daunting. It's challenging to envision what machines will become from someone else's perspective.
Yep, you're exactly right. And in order to realize and in order to visualize that, I started making these illustrations, and I call these illustrations transhumanism. Transhumanism is a philosophical intellectual movement that advocates for the use of modern, sophisticated technologies to enhance the human condition. These illustrations are abstract. They're a mix of wires, panels, blood, mesh, all different kinds of organic and synthetic materials. I was experimenting with these illustrations, and I was trying to see what the current material existence feels like or looks like. As you can see, it's highly contrasting. Machines and organic stuff is very mushy with each other, and it's not quite integrated with each other. In the second illustration, this is like a process illustration. So I make these outlines first, and then I paint the organic part first, or the synthetic part first, and then the other. So in this case, this is a spine. So I was thinking about maybe in the future we can 3D print spines with a material that is not bone, and maybe it's better than bone, more flexible, stronger, and it doesn't deteriorate as quickly as bones do. These are some other illustrations that I did, and the fun thing about these illustrations is that they become the seed for my projects that I do in the future. So I use these illustrations all over my projects. One problem that I had with these illustrations was that it was still not convincing enough, or you cannot think about machines of the future using these illustrations. So I thought maybe I could go into the world of 3D, and maybe I could design some machines myself. For that reason, I came up with the idea of designing low-resolution beings. I call my machines low-resolution because I bring machines from the future into the present, and in that transition, they lose their resolution. For example, if I try to play a 4K video on a CRT monitor, I can probably play that video, but it will lose its native resolution, and I can only watch that video in a lower resolution format. This is exactly how I design my machines, because today I don't have the technologies of the future. So what I can do is I can use the technologies of today and design machines that actually mimic the behavior of the technologies of the future, of the machines of the future. So,
I see, but a visual aid would be helpful. Could you show us examples of your low-resolution machines to help us understand this complex concept?
I knew that was coming. So let's start with the first project. My first project, it's called Naamyaati machine. Naamyaati is an Urdu word which means organic matter. So this is a machine that actually talks to organic systems like humans. This is what it actually looks like when you interact with it. It's a small little cuboid device, And you can use your hand gestures mid-air to control this visualization on the screen. And there's a few buttons on it that you can press, and you can go through different stages of a transhuman being evolution. So the 4 stages are human, initiation, the womb, and transhuman. So I have a video that you guys might like, and you can see how this thing works. So this was Babu, who actually helped me with this project, and we collaborated on this and we designed this machine together. So this was the rough sketch. I thought of putting a cube on a pedestal and then hiding a computer inside the pedestal, and then of course I'm putting it onto a TV screen. This is what it actually looks like. So it's a mix of 2 different materialities, of course, organic and synthetic. The base is made out of wood, and the top cuboid frame is made out of acrylic. It's laser cutted, and this is how I actually made it. There is a small numpad inside this brown little box, and I have a microcontroller chip in that synthetic box, and it is actually attached to 2 ultrasonic sensors, and they detect the distance of your hand from the device itself. This is a program, Max. We use this program to, well, in this case, I use this program to generate sounds with those numbers that I got from the sensors. And for the visuals, I used a program called Touch Designer, which Babu helped me with because he is a touch designer genius. Babu is, by the way, my DMI fellow student. He's also presenting today. This piece has been, I think it has been successful. It has been into many different venues, exhibitions and shows. This is at the Mass Art SOVA Gallery in South End. And it was also a part of my solo show at the Godin Gallery at Mass Art. Let's talk about the second project. It's called Embrace, and Embrace is a 360-degree tactile canvas, and you stand in the middle of it, and you can touch it, and it generates sound as feedback. So this is a machine that actually tries to embrace you, and you form this intimate connection with the machine when you're standing inside it. And when you touch it, it sounds pretty nice when you touch it. So this is a small demo video, and you guys can see how this thing works. This was the initial sketch before I started working on this project. In order to develop this project, it was a big project, so I had to go through different prototyping stages. So I had prototype 1, which was small. Well, for this thing, I wanted a cylindrical form. So I went out and then I stole a traffic drum, and then I brought it in, cut it up, turned it into this cylindrical form. And what I did was I pasted paper inside of it, and I, of course, printed my illustration on it. But then I used conductive ink to paint over it that actually made it conductive. And if you touch it, it sends a signal to the chip that's attached to this little device, and that goes into my iPad. So when you touch it, it generates sound. But in this prototype, it generated square wave sounds that are not very pleasant, and they sound like beep beep. So with the second prototype, I actually tried to fix that issue, and I wanted it to sound nicer. So I used the same program, Max, that I used before to generate sine wave sounds, which are pleasant to hear. And after that, I started working on my third and final version of this project. And this is how it went. I had to fabricate this 5 foot wide in circumference, a big giant cylinder. And Dennis Warnos, who teaches at Massart and also at BU, he helped me with that, and he is a great sculptor. So it was quite a learning experience. I learned how to cut metal, I learned how to bend it and weld it, and it took me about a week to do this. After that, I printed an illustration, and I painted with conductive ink on top of it, as I did with the first prototype. And then I pasted it, and Babu is actually helping me with it. After that, since the Godin gallery did not have any metal frame at the top of the ceiling, so we had to get this little, no, it's not little, it's quite big, a frame. So we attached this thing onto this frame. It was quite delicate, but we were able to pull it off. So these are some final shots from the show. I forgot to mention the significance of the audience sand that you see down there. Yeah, it does look nice, but it also serves a purpose. And the purpose is that it grounds you, that it isolates you from the ground. So, for example, if I touch the machine and if I'm standing on the floor, it doesn't really work because the circuit somehow, it's already grounded and it does not need a ground. So, I thought about putting some sand on the floor. So if you stand on the sand, it isolates you from that whole thing, and then the connection works. So we troubleshooted a lot. Fred helped me with it, and we finally figured it out. These are some other images that I really love. This is Crystal. She taught me when I was in my third semester, I guess. Was it the third? Yeah. Second? Okay. So this is my third project, Membrane. And with this project, I thought about octopus. Octopi are interesting beings. They are very highly adaptable, they're very intelligent. They can change their skin color, they can change their form and the texture that they have. They have color changing cells. So I thought maybe I can design a machine that's very organic and it behaves like an octopus. So I did that. And this is what it looked like. This thing does not work. So when you push into it, it actually sends light from the back using a projector. So it's a fabric, it's a flexible membrane. So when you push into it, it gives feedback. So let's talk about the first prototype. I developed this prototype while I was taking a class at MIT. It was a projection design and an interaction design class. So I was lucky enough to present or put my work in the Stata Center at MIT. I loved that building since I was a kid, and it feels like good to put your work in a place that you admire. So this is how I worked on the first prototype. It's kind of funny when I go back and push it. And I used a projector and a Kinect sensor. So what the sensor does is it gets an X, Y, and a Z axis map of the space. So when you push into that space, when you probe into it, it detects that and it sends the signal to the projector and then to a program. It's called Isadora. It's a very similar program to Touch Designer. So it's a data processing software, flow-based programming. So then it sends the signal out to the projector, and then the projector only projects where you push it in. So this is an example of that. So it does not matter where you push, it will only project behind the area where it actually goes deeper into that Z-axis space. So you can also touch in 2 different points, and it will still work. Thing about this project was that I wanted it to feel more like skin. So I thought that maybe I should order some latex that kind of mimics the skin and it feels like skin when you touch it. So I ordered some latex and I started preparing it. And it's really hard to work with latex because it involves different kinds of binders and glues and it's hard to figure out which one works the best. So I got different kinds of samples for this latex thingy. It had different thicknesses. So I chose this thickness which is very kind of similar to the human skin. So this was a small process video of how I installed it in the space. This is where I am figuring out the electronics and I'm putting the computer in there and the projector and the sensor. And this is how it actually came out to be. It was at the Boston Cyber Arts Gallery, the Fresh Media show that we did this year. These are some images from that installation, from that show. There are some friends. Avi's here, Babu is here, Mary Grant is here. And I loved this picture because I always love when children play with these machines because grown-ups are really afraid to touch things, to touch art, but kids don't care. And I love that because with the Naamyaati machine, Fish's kids were there and they really loved the installation. Similarly, in this case, Harry captured this beautiful moment and took this picture.
These are fascinating projects indeed. The membrane project is particularly intriguing. I am excited about the idea of having an organic body someday. Thank you for sharing your insights into the future. I will sign off now, and I hope to see you in the future. No pun intended. Goodbye.
Thank you, Lena. You were a great host and friend, and I hope to see you in the future. And I plan to live longer than regular normal people. And this is the final illustration, which is the cover of my book, which is called Low Resolution Beings. And if you guys want to talk afterwards, or if you guys want to know more about the things that I made, it's all in that book, which is over there. Now, surprisingly, whenever I practiced back home, I always did it on time, but today I have 5 more minutes. So we get extra time to talk about things today. Thank you.
I'll hand the mic to our guest